Well, hello and welcome to Hydrogen Energy seminar series between Cardiff University and the University of Wyoming School of Energy Resources. And today's topic, this is a March presentation, and today's topic is reliability of US electricity grid and prospects for hydrogen as a generation fuel source. Today is my pleasure to introduce Kara Fornstrom, who is the Director for Center of Energy Regulations and Policy Analysis at School of Energy Resources. And Kara has extensive experience in this field. She has served in numerous positions that are basically highlight her career as a experienced regulator and utility operator. And so with that, please welcome Kara.
Thanks, Eugene. Good morning from Wyoming. Looking forward to this opportunity to talk to you a little bit about some hydrogen electricity issues that we're seeing in the US. Next slide, please, Christine. Always like to start our presentations with just reminding the audience what our mission is here at the School of Energy Resources. We are focused on energy-driven economic development for Wyoming. We really look at incremental revenue opportunities. And so for us in Wyoming, that remains looking at our legacy industries such as coal, oil, and natural gas, but obviously working on a lot of emerging technologies as well, such as nuclear and of course hydrogen. Next slide, please. There are three pillars at the School of Energy Resources. We do have an academic program. We have our outreach department, which is led by Christine, I think many of you know. And then our primary function really is research, where we look across the centers on applied research, focusing on commercialization of new technologies for both our legacy and emerging industries. Next slide, please. The School of Energy Resources is organized around centers. I think you're all familiar probably with Eugene's center, the Hydrogen Energy Research Center. You'll see right above his box is my box, the Center for Energy Regulation and Policy Analysis. Next slide, please. At SERPA, we have three functions: research, policy support, and stakeholder engagement. Our primary function is research. We think we spend about 70% of our time here, again, producing applied research, impactful, high-quality work addressing issues of policy and regulatory interest to industries within Wyoming, maybe to remove barriers, make recommendation to policymakers, et cetera, to ensure that emerging technologies and legacy technologies can address any policy or regulatory issues that may be a hurdle for them. And so we get to choose from a variety of topics. I encourage you to go to our website and see some of our recent publications. Our second function is policy support. In this function, we spend a lot of time with the governor's office, the Wyoming Energy Authority, the legislature, other state agencies in helping them understand energy policy and regulatory issues. For example, right now we are in the legislative session in Wyoming, and so we do a tracker of all energy-related bills. We've been following the legislative process, trying to give heads up to people about different issues and provide information where we can. We also, as part of our policy support function, prepare briefing papers for policymakers to assist them in submitting substantive comments on proposed rules from the federal government. I'm going to talk more about that a little bit later in the presentation when we talk about one specifically related to hydrogen. Our last function is stakeholder engagement, where our team works with industry groups, energy-related groups in Wyoming, such as the Petroleum Association, the Mining Association, et cetera, to make sure that we understand the issues that they're facing. I call both our policy support and our stakeholder engagement functions our ear to the ground work. And really what's important about that work, not just in what we are able to do within those functions, but it really helps inform our research function to make sure we are producing productions that are relevant and helpful to those that we serve. Next slide, please. So today there are 5 topics I would like to talk with you about in terms of electricity and hydrogen. First, we'll talk a little bit about the state of the US grid, talk briefly about the DOE Hydrogen Hub recent awards. I want to spend a little bit of time on the Wyoming Energy Authority's hydrogen pilot projects. And as I teased a minute ago, we're going to spend some time on the hydrogen 45B tax credit and conclude with a brief discussion about 3 pilot projects on hydrogen electricity within the US. Next slide, please. So NERC is the North American Electric Reliability Corporation, and they are the regulatory authority whose mission it is to assure the effective and efficient reduction of risk to the reliability and security of the electric grid. NERC produces different types of reports to inform everyone about potential risks to the grid and sort of how they're seeing reliability in the US. They've been producing long-term reliability assessments since 1991. We're going to go through one of those here in just a minute. They also, in 2003, started producing both a summer assessment and a winter assessment that focuses specifically on that season and how the grid is looking going into those things. They also issue some special reports depending on different issues that arise that they believe may be of concern to the electric grid. When they issued their State of Reliability report in 2023, they issued findings. First, the conventional generation reliability is significantly challenged. I'm going to talk more about that in detail in a moment. Second is the solar PV inverter performance, that dynamic performance must improve. They cite a specific example in June of 2022 within the ERCOT market where 1,700 megawatts of solar PV resource power output was lost suddenly. And they're seeing it with these kind of inverter-based resources where performance can just drop off the grid. And obviously that's not ideal when you're trying to match supply and demand instantaneously. And so they're encouraging improvement on that dynamic performance. Third, physical and cybersecurity attacks are increasing. They called for adaptation of additional standards and guidelines to address those. And then as a bright spot on this report, they did note that the overall severity of outages related to transmission, not necessarily generation or distribution, has improved over the last 5 years. Next slide, please. So this slide has a lot going on in here, but I want to walk through this pretty carefully because I think this will give you the best overall view of what the US grid looks like from the perspective of NERC. One thing that they found related to that key finding number 1 was that in 2022, conventional generation experienced its highest level of unavailability, 8.5%, since they started gathering that data in 2013. So I'd like to start with the first column, looking at demand growth. And you'll see here a comparison of a couple of different things. The white bar is the 10-year summer growth in megawatts, and the blue bar next to it is the 10-year winter growth in megawatts. They've shown their large shifts in demand from the summer to the winter. And significantly, if you'll look at 2024, they're looking at significant projected growth in the winter months, which has caused some issues as the US grid has really added a lot of natural gas generating resources. In the winter, natural gas becomes a bit of more of an issue from a generation perspective because it's not just used for electric generation, it's also used in home heating. And so you have 2 types of utilities really fighting for the same supply. And while we have significant amounts of natural gas, in the winter, that gets a little bit more tricky with some freeze-offs at the wellhead, some limited pipeline capacity, the low ability to significantly in the February 2021 Storm Uri event where we saw load shed across the country, mostly because there were some other reasons, of course, but mostly because of difficulty in delivering natural gas to those regulators or to those generators. The expanded growth is also a bit of a shock to the system because over the last 10 years or so, we've had very limited growth in demand. We are seeing now a significant projected growth, which is attributed to electrification movements, but also to the addition of high electricity intensity industrial customers, such as data centers, blockchain, for example. As you probably know, those are very electricity intense industries, putting some stress on the grid because of the significant projected growth in demand. The next column of this graph focuses on the generation. So we were just talking about the demand side. Now we're going to talk about the supply side. And the lower graph on generation retirements is really highlighting the area where NERC is quite concerned. They are finding that fossil generation, which is dispatchable, is retiring early prior to the resources that are replacing it being able to replicate the reliability attributes of that thermal resource. Most of the additions to the grid are now intermittent resources and therefore cannot be called on at all times when demand surges, as we're seeing on that first column. NERC is estimating that 83 gigawatts of thermal generation is planned to be retired before 2033. And they are really raising the red flag about this, that the grid will be unable to operate with those kinds of retirements given the rate of additions to the grid that don't contain those same reliability attributes. The next column really focuses on the map that's shown above. And this provides a risk assessment in 3 different categories. High risk, which is shown in red, yellow, which is an elevated risk, and then the blue is sort of normal risk. And you'll see from the graph from the map of the United States that NERC has determined that almost all of the United States is facing some sort of risk. The southeast of the United States seems to be under normal risk, but there is high risk in the center of the country, mostly within the MISO market, where they anticipate capacity shortfalls in 2028 and note winter generation and fuel risk, mostly due to the natural gas issues that I was describing earlier. You'll see where Wyoming is located, we are in an elevated risk area. NERC is looking at different issues in the Western interconnection related to that elevated risk, but mostly they're laying that risk on the fact that we have insufficient dispatchable resources available. So again, back to the second column where we were talking about retirements of thermal dispatchable generation before those reliability attributes can be replicated on the grid. You'll see there then on the last column, the recommendations from NERC to address these elevated and high risk areas. It says they need to add resources that have reliability attributes, manage retirements, and make existing resources more dependable. The second point really has to do with expanding transmission networks to connect additional resources to the grid so that those supplies can be delivered to serve changing loads. The third and fourth ones are really just general recommendations in terms of planning, resource procurement, etc. There's also a recommendation within there that markets, electricity markets, of which we have a few in the US, should be looking at compensation for reliability attributes. That currently is not part of the system, although most markets are working on some sort of market mechanism to ensure that those thermal resources remain economic within an overall dispatch, so that when there are times of tight supply, those dispatchable resources are available to the grid. Next slide, please. All right, I want to briefly talk about the recent hydrogen hubs awarded by the Department of Energy. These awards amounted to about $7 billion. There are 7 projects that have been selected. I've listed them here for you. I'm not going to go through all of them, but I would like to talk about 2 of them more specifically because there are only 2 that contain an electricity production component, and that is the Heartland Hydrogen Hub and also the Midwest Hydrogen Hub. The Heartland Hydrogen Hub is located within the states of Minnesota, North Dakota, and South Dakota. They were awarded up to $925 million. While it is focused on those 3 states, it does have the potential to expand into neighboring states. And this project is really focused on 2 areas of hydrogen production. One, to decarbonize the agricultural sector's production of fertilizer and reduce the regional cost of hydrogen. It also proposes to use clean hydrogen for power production in a manner that may catalyze co-firing hydrogen in utility-owned generation across the country. Next slide, please. Oh, I'm sorry. We can go to this one. I wanted to just hit the Midwest Hydrogen Hub, which you can see there on the map. I believe it's Midwest, number 6. It's in the states of Illinois, Indiana, and Michigan, and its funding is up to $1 billion. DOE noted in their award notification that this hydrogen hub is located in a key U.S. industrial and transportation corridor, and it will decarbonize through strategic hydrogen uses, including steel and gas production, power generation, refining, heavy-duty transportation, and sustainable aviation fuel. They plan to produce hydrogen by leveraging diverse energy resources, including renewable energy, natural gas, and nuclear energy. I use this map just to show you the geographical location of the awarded hydrogen hubs. And you can see there are some pretty big holes in our country that are not represented in the hydrogen hub award notification. Wyoming was part of a application that was unsuccessful that would have filled in at least part of that area of the country, but we were not successful in getting awarded. So these are where the hydrogen hubs are going forward. Again, $7 billion, and we'll see what they can produce over the next few years. Next slide, please. In addition to the funding for hydrogen projects, I wanted to highlight some recent awards by the Wyoming Energy Authority on hydrogen pilot projects. Most significant is the first one, Black Hills Energy, almost $16 million, and this is a hydrogen demonstration project that will go specifically to electricity production. It will be a natural gas-fed blue hydrogen gas generator with carbon capture. And so this will focus on the blending of hydrogen with natural gas and potential modifications to those combustion turbines, how much hydrogen they can tolerate and they'll continue to monitor performance and see how those turbines do. But pretty significant award. That plant is located in Wyoming, and so we're excited to see what that study will produce. The second one is Williams Company, which is the Southwest Hydrogen Hub, nearly $2 million. This one is in partnership with the University of Wyoming, and we'll look at asset integrity in support of green hydrogen production and transportation. And then last is Jonah Energy, green hydrogen through power to gas study. This project is in partnership with the National Renewable Energy Lab to create green hydrogen and renewable natural gas through biomethanation. So in addition to what the DOE is doing on a federal level, Wyoming is also funding its own specific research related to hydrogen, and those are just 3 of the projects that we're looking at right now. Next slide, please. All right, I want to shift gears and talk specifically about a very recent proposal from the Internal Revenue Service, an agency of the United States government that will oversee the tax credit for clean hydrogen production. As I mentioned earlier, our policy support function at SERPA has us producing briefing papers, and we just completed this with the assistance of Eugene's team, especially Charles Nye, who helped us with some very specific comments here to help our policymakers weigh in on this rule. The IRS will consider the comments to the draft rule and issue a final rule sometime later this year. There are 6 major components of this tax credit proposal. First, it creates a 2-tier inflation-adjusted tax credit. The construction of these projects to be eligible for the tax credit must be initiated before 2033. The tax credit is then available for 10 years. This next requirement is one that we spent quite a bit of time on in our briefing paper in terms of production of clean hydrogen. And proponents of this tax credit, I think, had hoped that this might be a little bit more broad. There were a couple of issues here that we really focused on. One is the fact that it's a life cycle emission rate. And there was a lot of discussion about what that emissions rate should be. And the IRS landed on 4 kilograms of CO2 emitted per 1 kilogram of hydrogen. And they're looking at the life cycle component of this. So feedstock through point of production, also referred to as well to gate. So a very long span in terms of what the emission rate should be, and a standard that is fairly low, that I think many were hoping would be a bit higher to accommodate other types of hydrogen production. It also uses the 45V hydrogen GREET model. This model was developed by the Department of Energy in 2023. And one of our concerns about using that model, because of the life cycle emissions rate calculation, is there are some fixed assumptions within that model that cannot be changed. For example, the model assumes a 0.9% upstream methane leakage for all natural gas supply chain. Even if you have evidence, which I believe we do in Wyoming, that upstream methane leakage is not at that rate, we can't change that in order to affect the ultimate calculation of the life cycle GHG emission rate. In our view, this will eliminate a lot of options for production of hydrogen. Blue hydrogen, for example, will likely not be eligible for the 45V tax credit because of how this component of the proposed rule is structured. Interestingly, within the tax credit proposal, there's a multiplier. You get a ×5 tax credit if you meet prevailing wage and apprenticeship requirements. And so obviously a focus of the administration here on the workforce component of the tax credit. Last were some electricity source requirements, which I'm going to talk about in a little bit more detail here in a moment. Next slide. Before we get to that, however, I just wanted to show you this graph that EPRI prepared that in their estimation shows the impact of this potential tax credit on different types of hydrogen production based on the electricity source that they will have. So you'll see there on the far left in the green, this is an estimate of Midwest wind providing resources for hydrogen production. And you'll see without the IRA credits, it's about $5.50. And they think they can reduce that to less than $3 between the combination of IRA and the 45V tax credit. When we're looking at Southwest Solar, it's a little less than $6 without any of the incentives, and then below $3 once you add those incentives in. The last one in the gray really just lumps everything else together. So other regions of the country with other types of technologies, that was estimated at production of $7, and they believe they can lower that to $4. So this chart really shows the financial impact of those economic incentives for hydrogen production based on where you are and what your electricity source is. Next slide, please. Related to the electricity source requirements of the 45V proposed rule, it's really based on 3 components: incrementality, deliverability, and hourly matching. When we talk about incrementality, the proposed rule has landed on these being sourced by completely what they call green resources, renewable resources, no CO2 emissions at all. So that really limits the ability of a hydrogen production facility to be sourced by electricity. It also placed a new facility requirement on this part of the rule, which means that the electricity resource supplying that hydrogen production facility must have come online in less than 36 months prior to that facility being operational. The point here really was to require new hydrogen production to be sourced by new electricity facilities. They did not want these hydrogen production facilities to be draining, so to speak, existing renewable resources that were already on the grid. They believe that would increase the demand for existing fossil to stay on the grid, and so they wanted to make sure that new demand is sourced by new supply. Next is the deliverability component, which really is a geographic requirement. You must show that the electricity being generated is in the same general area as where the hydrogen production is occurring. So a regional kind of component to make sure that there's some correlation between the supply and consumption of that electricity. Interestingly, balancing authorities will make the determination, as the rule is drafted today, on whether that electricity is deliverable to that hydrogen production facility. Now, balancing authorities are interesting in the United States. The markets that we were talking about, one of the benefits of those markets is that they collapse those balancing authorities into one. So you have one entity trying to match supply and demand across an entire footprint. However, in the West, outside of California, where we do not have an electricity market, we have 39 balancing authorities. And so there's a lot of kind of patchwork of balancing authorities across the Western interconnection. And it's interesting to me to think about how close in line some of those are. For example, southeastern Wyoming, while adjacent to northeastern Colorado, they are in different balancing authorities. And so it's not clear to me how this will work if a generating resource is in one balancing authority and the hydrogen production facility is in another adjacent balancing authority, whether those two balancing authorities can work together to determine the deliverability, or if they have to be within the same balancing authority. So again, another limitation that may impact the ability to meet this component of the electricity source requirement rule, or part of the rule. And last, another limitation is on the hourly matching. So you must be able to demonstrate a correlation between the time of generation and the consumption. And we're really concerned about the potential incompatibility of this requirement with the first requirement of incrementality. If you are saying that these hydrogen production facilities can only be sourced from renewable resources, let's just use wind and solar as an example, the hourly matching requirement gets very difficult, especially for solar resources. And so we're not sure if this means that these hydrogen production facilities that are using solar energy, if they just will not be able to be operational in the non-sunlight hours. Obviously, there's the option of storage, but those resources have really not been developed to the extent that would be functional in this kind of scenario. Also, maybe with the wind, it would be even more difficult to predict when you are going to be able to operate your hydrogen production plant, because you'll have some idea, depending on how much you want to invest in wind forecasting technology. But if the wind is not blowing and you're not receiving any wind energy, will the plant have to be shut down? We believe these three requirements, when it comes to the electricity source requirement component of the rule, add a lot of hoops that you would have to jump through in order to be eligible for the tax credit, which is critical to the investment decision. We saw those price reductions. And so I think this component may make it difficult for investors to determine what kind of tax credit they'll be able to get because they'll have to try to anticipate how they will meet these three requirements of the rule. And I think altogether they could be fairly challenging to ensure that those are being met at all times in order to maximize the tax credit available under this rule. Next slide, please. All right, I want to finish this morning with just a quick, brief discussion of three pilot projects in the United States that include hydrogen into the electricity generation. Next slide, please. First, we'll start with Florida Power and Light Company. This is the Cavendish Solar Energy Center. It includes a natural gas generator that they're going to use solar energy to produce the hydrogen. They'll release the oxygen, compress the hydrogen, store it, and then ultimately blend it with natural gas within their existing combustion turbines to produce electricity. Right now, they're looking at a 5% hydrogen blend into one of the three natural gas turbines located at this facility. Next slide, please. The second project is one that was completed last year. I don't know that they have sent out the data quite yet. Upper Michigan Energy Resources pilot project. They wanted to reduce the carbon footprint of a 55 megawatt natural gas plant. Their goal was to blend up to 25% of hydrogen with natural gas. And they did different metric performance measurements on performance, output, emissions data. And early indications indicated they were able to reach 95% of their load, which resulted in an 8.5% CO2 reduction. So we'll see if that project expands from there, but early indications is that was a positive research project. Next slide, please. And last is the Duke Energy pilot project. This was announced late last year. They're looking to create an end-to-end system to produce, store, and combust 100% green hydrogen. Similarly to the Florida Power and Light project, it uses a solar plant. It's a 74 megawatt solar plant. They will store the green hydrogen and deliver it to one of their combustion turbines and test those results. They anticipate that this project will be fully functioning by the end of this year. So we have a lot of projects that we can be looking at within the US to see how hydrogen is being integrated into the electricity system. Next slide. So that concludes my remarks. I'm happy to answer any questions that you might have to my best ability.
Thank you, Cara. That was an excellent presentation. We'll wait for maybe a few questions from attendees, but if not, I have a few questions on my own. Yeah, I don't see any questions on Q&A or chat. All right. So in summary, that was very comprehensive presentation. But in summary, do you think 45V as is today benefits the hydrogen production for grid security, or it hurts it?
Well, that's kind of a tough question, Eugene. I would just say I think we were disappointed, just speaking for Wyoming now, about how limiting the 45V tax credit will be. I think we had hopes that it would cover resources like blue hydrogen, and it's clear to us through a couple of things that I mentioned that this will be a very limited application to green hydrogen produced exclusively by CO2 free electricity with those matching requirements and regional requirements. So I think my view is, again, my personal view is the way that the rule is crafted today, I think it will have much more limited applicability than many were hoping, and certainly within Wyoming, what we were hoping it would be. And so for those projects that can meet those kinds of requirements, and I don't know where those are going to be, it's very difficult to see. And again, from an investment perspective, an investor is going to want to know with certainty how much of that 45V tax credit they're going to be able to collect. And I think the electricity component of that is going to make that very difficult to calculate. But for those that are willing to do it and have favorable economics, it will provide, I think it will add electricity to the grid. But again, the hourly matching requirement, I think, will limit when that electricity can be contributed to the grid. And ironically, it may be in those times of stress where the hydrogen produced electricity will not be available to the grid, because it's at the same time that its electricity resources of wind and solar, for example, are not available, which is what's led to the system at that moment being under stress. And so I think the way that it's written today is pretty prescriptive and may really limit the ability of hydrogen to contribute in times of tight supply to the electric grid.
And this is the most needed time and sort of the point for all of this. Well, this is a complicated story, but thank you for your description. It is very helpful for me. Could you also say, what is the also kind of a general statement about potential future for hydrogen as you see and applicability for energy security in the United States? Do you think it's a path forward if, let's say, policy is fixed, or do you think it is still a problematic and sort of far-fetched idea?
Well, I think we're certainly making progress on that front. It appears to me that where we'll see the greatest contributions, given the way that the 45V tax credit has been written, and again, the pilot projects that we're seeing in the United States are coupled with natural gas. And to the extent we can expand the supply of natural gas through blending, for example, I think that's a positive development. And it appears from the literature and the things that I've been reading that those producers that are interested in blending hydrogen within their natural gas supplies for their existing combustion turbines will not look to 45V, but instead will look to 45Q in the carbon capture component of that. And so to me, just looking at it today with 45V written the way it was in the proposed rule, that the avenues for hydrogen production with the electricity supply chain in the US really will be, right now, it looks like combined with natural gas, some sort of blending, taking advantage of 45Q tax credits instead of 45V. I think it's going to take some time under 45V for those projects to come online. And not only are those requirements on the electricity generation restrictive, but you have to be sourcing a resource that's been built in the last 36 months. It has to be in your region. It's going to be challenging to try to put all three legs of that stool in one project and have it contribute in any significant amount to the grid. So I think those will take a little bit more time. But as you could see from the pilot projects that I indicated, both from utilities that are taking this on their own, what we're doing within Wyoming, the Black Hills project, those are all natural gas generators that are looking at blending hydrogen. And so I see those moving forward more quickly. They're receiving financial support, both from regulatory bodies within states and with funding resources like the Wyoming Energy Authority. And so I think those are going to be very interesting pilot projects to see what they can produce and how they can contribute.
Well, if there's no additional questions from attendees, let me check the Q&A. I don't see any. I think we can adjourn. Thank you very much for your perspective, Kara. I think it was very helpful. It's very comprehensive and very interesting to hear your perspective on this very broad, very complicated issue.
I appreciate that, Eugene. Thanks so much for the opportunity. Really enjoyed it.
Thank you.